Mr. McGee, did you ever get Skyrim?
There you go.
Get it.
Okay, so we brought up the issue of domain and range, correct? So in pre-calc we learned about some of those issues. So let's just summarize all the domain and range issues. So domain. Somebody tell me what that is again?
It's the x values.
Your x values, all the x values that exist on the number line?
No, the maximum.
On the equation.
Well, good, on the equation. I like that, Austin. So it's your possible x values as defined by what's possible for that equation or that function, hopefully, right? Your range is therefore the possible y values that you can obtain. The nice thing in math is that there's some quick rules of thumb for domain figured out for like any class of function. Now you haven't seen every class of function in pre-calc, but you've seen almost all the elementary functions. There are other ones that are more exotic, but you've seen the majority of them that you need for math, okay? There's some quick rules of thumb to come up with this. Range is a trickier issue. Range is a much trickier issue. We tend to avoid it or use our calculator to look at the graph a lot of the time. Okay. Well, let's look at those rules of thumb again for this. So domain issues that could happen. I think we can put them in 4 categories. 4 categories, that's all you need to know. If you have a rational function, the bottom can't be 0 because it'd be undefined. So you got to watch out for those. Bottom can't be 0 if you have a fractional function, which we call rational. What's another thing we have to watch out for with domain? Can someone remember?
Square root.
Square root?
Yeah, negative.
Negative square, it's the I.
Yeah.
Imaginary.
So how would I say that? You guys are onto it.
Just put the I there.
Imaginary
I don't know what you
numbers.
mean.
You gotta watch out for imaginary numbers that come from the inside of a radical. Just square root?
No.
Any even root, right? Odd roots are okay, they have domains.
So do we just put inside a radical? Or is there
Inside a
something-
radical, let's put an even radical. Has to be greater than or equal to 0. If it's not, it's complex. Excellent. Those are the 2 main ones. What are some other ones? 2 other issues. What other kinds of functions we have? Think about it.
You have like piecewise.
That's just a combination of other ones,
That's
though.
just, yeah.
Is there something with an absolute value?
When it doesn't
Logarithms.
work, when you break the function, you can't break the function.
Right, but these are ways to break the function.
Oh, dang it.
Inside any kind of logarithm has to be strictly positive. Why? Think about the shape. It looks like this because of that asymptote. Only way you could possibly get values over here is by doing something with absolute value or something like that. Right?
So that one's just greater than 0, but the other one's greater than or equal to?
Why? Why can't this one be equal to 0?
Is it 0, 0?
Because it never
Or no?
touches 0.
It never touches that asymptote. Logarithms look like that.
Sounds
Okay.
about right.
Number 4, we're going to group kind of a lot of things together here. What other kind of functions do we have? We spent a lot of time with them during the second semester last year. They had like, I don't know, sines and cosines. Sines and cosines, any domain issues there?
It goes 1 to 1.
Cassidy, Kyle. Okay. Sine and cosine are fine, but other functions, other trig functions, they all have what? Tangent.
They all have
Asymptotes.
asymptotes.
They all have asymptotes, and each asymptote is a hole in the domain.
It's an impenetrable
So let's
area.
put asymptotes. If I can spell it.
It's a hard word.
Of trig functions. How many of them do we have to worry about of the 6?
4.
4 out of 6. Those all have.
What are they? Tangent, cotangent.
Secant and
Cosecant.
Those are the ones that have asymptotes. Yeah. Okay. So let's find the domain of each one of these.
I love that song.
I hate it so much, but it's not my head.
Who's it that?
One version.
Oh, I know what you're talking about. They played it at the Rapids game this
I have
Saturday.
an original for one
Like that.
version.
Don't Never say that again. I have an erection from One Direction.
Wait, like.
You know we're on camera. They heard you say that.
That's okay.
Feel good about yourself.
I do.
You said it
No.
a lot more
I
loud
cry
than
when I
that.
laugh. I cry when I get embarrassed.
I cry when I throw up.
Okay. So like I said, computing the ranges of these things is much more difficult than the domains. For domains, you just have to know these rules of thumb. We'll look at the range of maybe the last one. Sorry. To know the range of the other ones, you have to be able to picture the graphs in your head, or with a calculator. Once you have a picture, it's not right. Okay, we don't have the picture, we don't have our calculator in any of these. I certainly hope we don't need it. Okay. What kind of issue does number 1 have?
3 and negative 3.
Yeah, you can do that.
How many issues? How many holes in its domain?
2.
How do you find that?
Oh, no, 3 because 0 also.
Rewrite this as
Does a 0 would break it?
0 breaks it,
Three
negative 3
negative.
breaks it, and 3 breaks it. So I should write its domain. Remember, there are 2 ways to write intervals of values. You can write the interval notation, that's the true calculus notation. On this case, I don't think it's really as good though, because you'd have to go negative infinity to,
Yeah.
what's the first
Negative
one?
3.
Negative 3, then
Negative 3 to 0.
negative 3 to 0.
And then 0 to 3. And then 3 to infinity.
Oh, yuck. Interval notation, even though it's easy, can be a pain,
And
right?
there's the one with the X, like in some weird symbol.
Right.
And
So this is the set notation.
Yeah.
Sometimes one's better, sometimes another's better. When you're doing these problems, I don't care which one you use. Try to pick the most efficient one. Think about it. If you've just got 3 points you want to talk about, you should say those x's such that x does not equal, like Caitlin says, what don't we want it to equal?
3, negative 3, and 0.
There you go. It's everything except those values. Done. That was faster this time. I like that.
Me too. I like that.
I used to prefer interval notation. Now I prefer set notation. Depends on the problem. Okay. Can you guys help me on number 2? What issue are we going to have with it?
Oh, the
Negative.
square root.
It's got a square root, so we've got to watch out for negatives inside. Don't make this hard. Set the inside no matter what it is. Sometimes it might be a parabola, so you might have to use a critical point chart or something. But in this case, it's just where that thing is bigger than 0. Is it okay for it to be 0 in this case? What's the square root of 0?
No.
Yeah, it's okay because
0, so it's
when you add
okay.
it,
Caught it.
So this is simple. You just go like that. So anything bigger than negative 7 is okay.
So then how would you?
Now you're not thinking about this and trying to say, oh, okay, negative 7, that's okay.
Yeah.
How about negative 6? Yeah, that's okay. Negative 9. No, that's not okay. And you don't have to guess. You just write it down like that.
So how would you write that in the?
In this notation, you'd get x such that.
X.
X is greater than or equal to negative 6.
Done.
That's another case where it's just to write it like that.
Oops, wrote that on the wrong one.
Okay. I think this one's equally. But yeah, good point. You could also write the domain as negative 7 bracket up to.
Infinity. I guess that one's the same.
Yeah, that one I don't think it matters. Okay. Number 3, we gonna have any issues on that one? It's one of those 4 functions, right? It has asymptotes. So I think we better draw this. Its period, by the way, what's tangent's period start out as?
So
we go
pi
pi
over
over
2.
2.
So it's a tangent line at every pi over 4.
So we straddle, yes. This is pi over 2 wide, so the
Pi over
asymptotes
4.
are here. Do we agree? Any questions?
I don't understand, but it's okay.
This is 1 period, Austin, right?
Why is it pi over 4?
Because
With the
it's
2 inside
half
the X.
of pi over 2.
Because the period.
So that is 1/2, so
Oh,
half
so
of it
yes,
on
and
each
that's
side.
because the 2's in with the X, right?
I don't know.
Yeah. Because it,
Yeah, that's why it changed from pi.
Okay.
Then I had to go an equal distance out on each side and still get 1/2. So I had to go 1/4 out each way. So then you'd keep going, but you guys already were talking about it up here. How can I express the domain? You guys help me? I think this notation is much superior here. What's going to be the problem if you try to do this?
Your brain is
Do
going.
those asymptotes ever stop?
No, you're never
So how
gonna-
many of these are you going to have to do?
Infinity.
Infinity.
Infinite.
Never.
So you
do that.
can do the for x such as x does not equal pi over 4 plus pi over 2k.
You guys hear Caitlin?
Plus or minus.
Plus or minus. We don't need the plus or minus.
No,
We can
'cause-
just go
yeah.
plus pi over 2k.
Or minus pi over 2k.
You can put minus in there if you like. It doesn't really matter. But when you say k is an integer,
That
it
could be
covers
negative.
covers the negative integers too. But if you did plus or minus,
I
you'd
remember
still
doing
be
this
alright.
last year. It's coming back to me.
K is any integer. If you write something like that on the exam, you better make sure you put that part.
Or they'll get.
Can I just put W-I-A-K?
You might get away with it. I'm not sure on that one.
Can I put that?
Most issues will have a finite answer. I know what you can get away with. That one.
W-I-A-K.
It could be a little bit.
Yeah. Where K is an integer.
Okay, that one. Any issues with the first part? Just a line. Don't have to worry about it.
That one has the
you have
issues
to be
with the
negative.
square root, and it has the.
Maybe we better just draw. I think that's a better way.
I don't know how you draw that.
This is a line. It starts right there and goes down 1 over 1.
And it stops.
It stops right there. Should
with
it be
a
an
hole.
open or closed circle?
It's an open circle.
Open circle. If you're not sure on a piecewise function like this, you should plug in the edge. If you plug in 1, you get minus 1 is
0.
so that's indeed that point, correct?
Mm-hmm.
Now if you go square root of x minus 1 and you know your transformations, you say that's just square root of x shifted right 1.
Yeah.
So doesn't it fill that in?
Yep.
There's our picture. Should be easy to do the
It's
domain and
infinity
range
to
now.
infinity.
Domain is infinity to infinity. What's the range?
0 to infinity.
Bracket or parenthesis?
Bracket.
0 to infinity.
Why is that?
Now, you guys tell me.
It's a whole-
I thought we had an issue. Riley, didn't we have issues with square root functions? Do we have to worry
But
about?
that one makes up for it.
So there's some, when you have a piecewise function like this, you gotta look at them separately and then
Together.
together, right?
Why is the range
So
zero?
separately, this one is supposed to be
Because
x
it-
minus 1 greater than
Because
0,
why?
right?
Because they never go underneath.
So it'd be x only
Oh.
greater than or equal to 1, correct? So we'd
But
say the domain
one
is
is
1 to
taken under
infinity.
there.
But see, this part fixes it. Can't have that happen. Alright, let's stop there for today. Got a little bit more, but not too much.
Alright.
Alright, so you guys have that, so do tomorrow.
We still have
I'm gonna do a work of math next hour. Do you have
20 minutes-ish.